Welcome to Talk Tech with Data Dave. I'm Alexis, and I am a super non-technical person who works at D3 Clarity with my friend Data Dave. And we're here to talk to you about all things technical and, more importantly, all things data.
Good morning, Alexis. This is Dave Wilkinson, Data Dave, as you know me, from D3 Clarity, and I'm the CTO and founder of D3 Clarity, and we're here to answer whatever questions we can about data and anything else technical.
That's awesome. Let's get started. Talk Tech with Data Dave is brought to you by D3 Clarity, offering clarity for improved decision making. D3 Clarity delivers profitability multipliers through better data and digital infrastructure. For more information, contact D3 Clarity at d3clarity.com. So our question today comes from actually my husband. He works for a company that has an on-prem server, and about once or twice a month, I hear him say, the server was down all day today, we couldn't do anything. And I keep telling him that he needs to get on the cloud. And then he's like, well, tell me more about the cloud, and I never have the answer. So I'm going to ask you, Dave, what is the cloud that we hear so much about?
Very broad question. What is the cloud? In computing terms, not in weather terms, I presume.
Yeah.
So let's talk about the cloud for a minute. There is no real magic in the cloud. The cloud is really a collection of assets, a collection of infrastructure. Realistically, what it comes down to is a whole racks upon racks of computing equipment that is sold on an on-demand or a shared basis. So you purchase from one of the big cloud providers, who are some of the largest organizations on the planet, by the way, compute power, so you don't have to buy your own, right? So if you go to Amazon Web Services, which is their cloud, they have data centers, very large data centers all over the world that they sell to you, that they lease portions of to you, so that you can perform your tasks. So instead of buying a physical computer, you simply buy access to a computer, right? So you can go to, as an individual, you can go to the Amazon cloud or the Microsoft cloud, Azure, or the IBM cloud, or Google cloud, and request access, purchase access to a computer. And you get a Windows or a Linux or whatever front end that you want, you log onto it, and that is a computer that is running somewhere else. Now, that's the basic structure where you purchase essentially on demand. So you purchase by the minute or by the hour or by the year or whatever, and you get access to a computer of various sizes. So if you want to do, you've got your web browser, it means you can do things like take your very, very small laptop or even your phone and get access to a very, very powerful computer for a period of time, right? And then you purchase the services that go on it. It's essentially compute power for rent.
Compute power for rent. So
Yes.
Is that cheaper than buying it?
So it is often more convenient, and sometimes it is cheaper because you can rent it by the minute. You don't have to own it. You can also scale it up and down. So you can do fancy things like, most of the day, I need to do my email. For an hour a day, I need to do something much more heavyweight. I need to run some big analytics on a spreadsheet. So I boost up for that hour a day the power that I need, and I just rent it for that hour.
Right, because if I was purchasing it, I would have to have the bulk amount of speed, like the highest amount of speed all the time, right?
Exactly.
There would be no scaling ability.
Exactly. Think about it like renting a truck, right? You don't have to buy a moving truck. Every so often you have to move house. So you rent a truck and you put all your stuff in it to do it. If the truck wasn't available to rent and you had to buy it, you'd have to buy that truck and it would sit in your driveway all year, right? Doing essentially nothing. You'd have your little car for every day and your big truck for occasionally you move house or occasionally you buy some mulch or whatever it is, right? So you have this truck that you don't use very often, but you've paid the price for it. You've paid the taxes, right. You keep it on the road, everything else. So it is way more convenient to go to U-Haul and rent the truck when you need it for the period that you need it for. right?
That
So
makes
you
total sense.
so you can go buy the power that you need for a brief period. We do all our analytics, right? So we do, you know this, we've all got our personal laptops, right? But I've also got access for what I do, right? For our clients, I've got access to our own cloud environments where if I want to do some data analytics or some data mining or so on for a client or something, then I will go and rent in an environment the compute power that I need for that period and just for that period. And then I can keep it isolated. I can say, this is this client's data in this environment. I'm going to do this with it. I need this much power to do it in a week. I'm going to have it for only a week, and then I'm going to delete it again. I'm just going to throw it all away. I don't have to buy servers. I don't have to install them. I don't have to plug them in. I don't have to do anything else. I can put it all in the cloud on one of these machines that is in Amazon's data center or Microsoft's data center or Google's data center.
Well,
Does that make sense?
that leads perfectly to the next part of my question, and it's the question that always comes up. The company that he works for deals with a ton of proprietary information, and
Okay.
so they're spread out across the United States. So
Okay.
the the server that they're running, they're securing on their own. But if you open it up to the cloud, is it even a secure option?
So absolutely, the cloud can be very, very secure. It can also be very insecure. So if you think about it, right? So the cloud has the capability to be very secure. Microsoft runs their business on essentially their cloud. Amazon runs theirs on essentially their cloud. The way a lot of these came up was people running large businesses on these large computer data centers and realized they could sell the compute power and sell the structures that they reside in to people to run their businesses. So when you purchase environments or private areas in the cloud that has um, equipment or services provisioned into it, and you can prevent anybody else. You can lock that down. And the providers like Amazon, for example, have data centers all over the US and all over the world. And when you purchase from them, you purchase just this infrastructure, these assets that are in your private area. So you build up this little environment, which is like a server room, but it is virtual and it's living in Amazon's data center. Well, this is Amazon. They'll put way more money into securing their data center than you will. They've got
That's true.
armed guards walking around and badge access and limited people and everything else. And if you read the sort of HIPAA requirements for data, it goes down to what kind of room it's got to be in, what is the power supply for the room, how secure is it that it's not going to go down, how secure is it from a physical point of view if somebody breaks into the compound that it's in, etc., etc. There's a lot of specifications. Well, Amazon has done all that for you. You don't have to worry about whether it's in a locked room or anything else. And then they also wrap it in layer upon layer of virtual security, right? Firewalls, security groups, security structures. You have to tunnel into it. You've got secure tunnels going into it, VPNs going into it, etc. So it can be extremely secure and is built to be extremely secure. And we now put a lot of proprietary data, healthcare information, PCI type information, private credit information, and health information on the cloud because the cloud can actually secure it probably better than I could, certainly in my office, but in my local shared provider, right? So you do have layers of cloud where you can do co-location and full cloud, but the construct is you get the private area on somebody else's server farm in somebody else's data center, and you can access it in the way that you want to. Does that make sense? So we spend a lot of time setting up these for some multinationals and setting up secure environments for multinationals to host both credit information and health information.
So when it comes to security on the cloud, I'm going to recap quickly. There's a way to do it probably from a physical perspective, the cloud is more secure than an on-prem server. But from a digital perspective, there's a way to do it securely, and then there's a way to not do it securely. And then there's answers to do it securely that are readily available, and there are people who are available to help you with that, namely D3 Clarity.
Absolutely. So we can absolutely do that. And if you think about it, which is, um, think about it this way: you've got a server, and it's a physical server that's somewhere, but it's virtually somewhere away from you, right? So we can connect over the internet, we connect over whatever, we can tunnel into it, you can do private connections into it. But if you think about it, you've got a server, you've put it in a virtual box, right? You can leave the lid open on that box and you can leave it on your driveway, right? And everybody could see it, right? That would be an insecure setup, right? Or you can take that box and put it in your private world. You can put it behind another box. You could put another box on top of it and close all the lids and put a chain around it and lock the chain, right? And only you have the key, right? And then you can get into it. So you can set it up insecurely. You can set it up very securely. They also have services readily available for things like how to connect this machine to the internet. I want it to be a web server. So it does need a public open address that people can hit, but this is how you build one of those. So your data is secure, but your website is open. So they've got best practices for everything in between and connections to things like the domain name services. So you can find it with a human readable name, public IP addresses, private IP addresses, different what we call subnets, when we put computers in different logical places on the network, so that you can't access areas of your set of infrastructure, your set of services. And so they've got a lot of services. You can also, not only can it be computing, you can also do things like, now they offer things like databases that aren't associated with a physical piece of equipment. You can just buy area in a database. So you can buy a certain amount of storage that you access in this way. And it's just a database in the cloud. You don't know what piece of equipment is it running on, and you don't need to. They then guarantee the uptime. So they can say, we will guarantee 99.9% uptime on this database. And all you get is essentially the coordinates of that database. How do I connect to that database in a secure manner? And they do the rest. It's very, very convenient.
That sounds pretty similar to what my husband's situation is. And I always say that the reason he needs to get on the cloud, their company needs to get on the cloud, is because the server goes down so often. And with a company like AWS, which is like a huge sponsor of the NFL, so everybody that he works with like at least knows what AWS is. With someone like AWS, like it's so much less likely to go down, like you said, 99% uptime, but also and I know I'm not getting this right, so I want you to help me here. There's a lot of duplication of efforts, right? And that's how they guarantee the uptime.
Yes. So there's different ways of guaranteeing uptime. First of all, they do they offer a commercial SLA for the uptime, right? Now you can crash it yourself, and they don't take responsibility for that, clearly, but they do take they do take commercial responsibility. So they will provide backups, they will provide restarts, they give you the ability to just get a new server, right? If the server goes down, you just get another one. Right? Because you don't have to buy it. They just provision another one. And if the hardware has failed, they just take it out of service and you cycle onto a new piece of hardware, a new area. They can also do backups, either local backups or what they call different availability zones. So you can be secure around, okay, they have physically separated availability zones in each region, so that you've got separated by a certain number of certain distance. So if an earthquake hits or a tornado or something, then they're separated by short distance. You can also build it where they've got different data centers in different regions around the world. So between London, Dublin, Virginia, Ohio, different regions around the world. And most of the cloud providers provide this kind of capability. So you can build it to be very, very reliant and very locally accessible. Or you can start small and just build it like it was in your closet, and you just open it up and slowly evolve into being a very secure and structured environment.
When you're talking about migrating services one at a time from the on-prem server to the cloud,
Mm-hmm.
there has to be a period of time when the people are using both, the end users using both. Does that create any sort of, I don't know, hiccups or problems that are easily foreseen that we can plan for?
Yes. So it can do either, right? So yes, we can plan for them. Yes, it can create them. And whether we do them one at a time or whether we do them all at once is the choice of the client, right? So if there's two services, I'm going to call them services, if there are two services that are tightly coupled and talk to each other, then we probably do those ones at the same time. If there is a group of people that use one service exclusively, right, they live in a customer service app, then why wouldn't we do that one, move all those people off, they're using the cloud service and then they're off the on-premise service. So there's ways that we design it to make sure that this migration period is as short and as unintrusive as possible, right? So you're not making people, data's in two places. I use this app over here and that app over there. We try and hide that, try and make that as seamless as possible. And we try and look at how are people accessing these applications or these services, and how can we design it so that it's as seamless as possible during this migration period. And then ultimately, like I say, shut off the on-premise one.
And that's the bonus of having an expert team helping you when it comes to something like this, because our team and other teams like ours have seen this happen many times, and we can help foresee some of those issues. Is that what I'm hearing you say?
Yeah, no, absolutely. I mean, we've seen, just talking to people casually, we've seen things like people have left their whole data warehouse open to the entire internet. So, design it to be secure, work with it to be secure, and design the migration to be convenient for you, and then work through that. The devil is always in the details, right? There's a lot of moving parts in the cloud. It can be simple, but it's like, driving a race car. Okay, it's as easy to drive as driving your Prius or driving another car, right? It's pretty much exactly the same as driving any other car, but it will also do damage. It will enable you to shoot yourself in the foot. It will enable you to drive too fast around a corner and spin out. It doesn't put the brakes on for you, right? So one of the things is hire a chauffeur to drive that car for you, right? And then we will design the security infrastructure. We will design the scalability infrastructure. We'll design the access infrastructure, etc. And then a migration project that will move you into there in a nice, comfortable manner. And you get to go out to dinner in a nice limousine rather than having to drive a race car.
I love that. Thank you, Dave, for giving me that crash tutorial in the cloud. I feel like I walked away with a lot of good information that I'm going to share with my husband and then force him to listen to this podcast.
Excellent. I hope he asks another question from it.
Thanks, everyone, for listening. We hope you have a wonderful day. If you have a question for Data Dave, reach out to us via email at talktech@d3clarity.com. We'll be happy to answer your questions in the podcast. Thanks. This podcast has been brought to you by D3 Clarity. No one has time or patience to fix all of their data and infrastructure problems. D3 Clarity helps some of the world's most recognizable brands take the right action to turn their information into strategic profit making. For more information, go to D3 Clarity, that's the letter D, the number 3, the word clarity.com.